Now let us prove this law of cosines here. And the following technique is called the coordinate geometry. This is a plane geometry, but we put this into an xy coordinate system, and the algebra is available, and many of the plane geometry proof can be done very straightforward, an algebraic calculation in the xy plane. So we're going to put this triangle into an xy plane. So from here is the proof of the law of cosine, and here's our xy plane, and we're going to put this baseline in here with this angle down there in the left corner being the origin, and here is our length A. Okay, so that coordinate, because we're putting the coordinate geometry, and this is a coordinate here, is going to be A comma 0. It's on the x-axis. Make sure you understand that all the A, B, C involved in that triangle is all positive. I'm going to pretend the angle here is an obtuse, so we're going to be over here in the second quadrant. So this side over here is a B, and this side here is a C. That side over here is a C. This is angle between 0 and 180 degree, so we better put this in a circle situation so it can relate to values of the cosine in there. So the following is a interesting part. We're going to draw a circle with this center here and here with the radius B. So this is my rough picture. This is a circle with radius B and centered at 0, 0. Right? So that becomes the terminal point of the angle theta in here. I'm going to put in theta in there. And this will be a coordinate x and y that we don't know yet. But it corresponds to this angle theta and the radius B in there. So that's the situation in the xy plane. So we're going to write down a few facts. First of all, the first thing is this point x comma y is on this circle. So we have a Cartesian equation x squared plus y squared equals radius of that circle here is given by this positive number b squared. So that's the one fact we know. The second fact is about this length between those 2 points x comma y and A comma 0. This is where really the coordinate algebra kicks in and becomes really powerful and turn this plane geometry problem into a simple algebra problem. Right? So we're clearly looking at this as x comma y on that circle and A comma 0 on the x-axis. Then if you look at these 2 points, this length is given to c. That's a part of our condition. So I'm writing here the c. Number 3 is that there are different ways to calculate this length using something called the distance formula. So in number 3, we're looking at the same object, and the length between x comma y, A comma 0 is given at c, but if you look at these 2 points, we have a distance formula to calculate this length between these 2 points. It's by distance formula. If you apply distance formula to this point, remember there's a square root, and between x, a difference between x and x coordinates of these 2 points, which are x and a, so you have to subtract it and square inside. If you look at the y coordinates, and that will be y minus y coordinate, there's a 0. This is called distance formula. If you have 2 points in the xy plane, this is how I calculate distance between 2 points. So this is simply root of x minus a squared plus y squared, and all over. So this is interesting part. If you look at number 2 and 3, we're talking about the same thing, and one part's given, and another part we have a different way of calculating the given part c. So we can set these two things equal to each other because they are the length of a same line segment. So that will give you a relationship between x and y and c. So let me write down over here. So we can say that c, which is the length of these 2 points in here, is equal to this value in the square root. It's the square root of of x minus a squared y squared there. Well, our goal is that what is given here is a and b, and theta is given. If we can relate this a and b and theta to this x and y value, then we can turn this equation involving only a and b and theta and c, and that is our goal. So first, we're going to get rid of the square root and think about how to change this x and y value there. So how do we simplify it? To get rid of the square root is, of course, squaring both sides. So we have c squared equals x minus a squared plus y squared. And I have copied that picture down here. So that's what we have, and see how further we can simplify this. So here's left-hand side is a c squared. Right-hand side, if you expand this one, it's not x squared minus a squared, but we have this binomial expansion. So we have x squared minus 2ax plus a squared plus y squared. So this is an equation that involves everything we have written down here. Again, our goal is getting rid of this x and y, change this x and y in terms of a and b and theta. Think about how this x and y and a and b and theta are related. That is, of course, the definition of a trigonometry that I remember the cosine theta. Let me just circle it, bullet item. The cosine theta is x coordinate divided by the radius. Here is b, and sine theta is y coordinate divided by the radius b. So you can write x here as b times the cosine theta, and here y, y equals b times sine theta. B times sine theta. That's what you can replace it over there. And I wrote down here also another thing that we're going to use is because we see this x squared and y squared showed up. If you recall the fact that the Cartesian equation of the circle, no matter what the point is on the circle, x squared plus y squared is always b squared. Since there's x squared and y squared, that's the first thing we're going to do, and rest of the part we will use this definition of cosine and sine to replace every x and y in terms of b and theta in there. So next part is that I'm going to reorganize it like this. C squared is I'm collecting x squared plus y squared. Together we know it's going to be b squared. That's why I'm organizing it like this. And there's this a squared out there and 2ax squared. So I'm replacing in here that x squared y squared with the b squared. That's a Cartesian equation. We have a squared. So we already have this nice term showing up. It looks a lot like now law of cosines. C squared equals a squared plus b squared minus 2ab cosine theta. So this is the only part here. This is the only part that is not written in terms of a and b and theta. So how are we going to do that? We definitely use this cosine part here, cosine theta. From that equation, we learned that x is equal to b cosine theta. So that's how you replace x with b and theta in terms of b and theta. So here, next line is a c squared is b squared plus a squared minus 2 times a. That x part is replaced by b times cosine theta. And if you organize it like this, you can change the order of a sum of two numbers and put them together to negative 2 times ab and cosine theta. And this was the statement we wanted to obtain. It's known as law of cosines. So that's the end of the proof.